Hello, everyone. Mr. Sanford is back with a fresh haircut for the spring. We're moving on from chemistry now, and for the next little bit, we're going to look at climate change. But before we can really discuss climate change, how it's changing, and why it's changing, we need to look at the factors that affect climate in general. So, this presentation might be a bit of a review for some of you from what you learned in grade 9 geography. If not, then you'll be hearing this for the first time. And remember, these are ways to establish baseline conditions so that we can understand how those conditions are changing, and in particular, how human beings are influencing the change of climate. Okay, before we can discuss factors that affect climate, I'm just going to move my face out of the way here. We need to talk about the difference between weather and climate, because these two concepts are often confused and by people that often are making policy decisions. So you sometimes hear people confusing weather and climate, and they're in positions of power that are actively making decisions about climate change and our future on the planet. So weather looks at very short-term conditions in the atmosphere. So when you check the forecast, you look at the Weather Network or you go to theweathernetwork.com, you check the forecast for London. The things that they talk about are short-term conditions such as the temperature, the wind, humidity, referring to how much moisture is in the air, the pressure. So when the pressure drops, that means air is rising rapidly and you're likely to have some bad weather coming in. Precipitation. So the other day, a couple days ago, it was raining pretty hard. A couple weeks ago, it was snowing, if you can believe it. That's all weather, very short term, hard to predict because a slight change in the wind can cause it to rain in one spot and not in the other spot. And you'll be blaming the weather person saying, hey, you said it was going to rain and it didn't, but it did rain down the street. Maybe it rained at your friend's house. Very difficult to predict. Climate, on the other hand, looks at long term average conditions in the atmosphere. So it looks at the long term average weather in a particular area. And that's much easier to predict. It's easy to predict the climate in London, Ontario. This summer, it will be hot. It will rain on occasion. It will be very humid. In the fall, it will be cooler. It will still rain. In the winter, it will be cold. It will snow. That is easy to predict because we have a lot of evidence over a long period of time that that's how the climate works in London, Ontario, Canada. And that depends on factors, bigger factors, things like our latitude. We're not changing, we can't change our latitude, our position on the planet. That depends on things like altitude. How high are we above sea level? Again, not something we can change. The winds, even though they're variable in the short term, in the long term, they're actually very consistent in terms of where they come from, which direction they come from, and on average, their speeds. And again, distance from large bodies of water. So we are in a unique position in London, Ontario, right in between the Great Lakes. So to the west of us, we have Lake Huron. To the south of us, we have Lake Erie. To the east of us, we have Lake Ontario. So again, we're not changing that position, but each of those influences the overall climate in London, Ontario. So now that we know the difference between weather and climate, we need to, again, figure out what are those factors that affect climate so that we can establish a baseline. What is the average condition like? How has that been over the last many years? I said 30 years earlier, but we can go back hundreds of years to take a look at this information so that we can know when a change is happening. And then furthermore, we can investigate why that change is happening. And as a sneak peek, yes, climate change is occurring. And yes, we are the main driver of that climate change. So, factors that affect climate are one, latitude. So, latitude refers to how far north or south of the equator The equator's at 0 degrees latitude. That's that band around the center of our planet. How far north and south of the equator are you? That's measured in degrees. And in London, we're about 43 degrees north. So we'll talk about each of these, how it actually causes or how it actually influences climate afterwards. Ocean currents. So depending on where you are on the planet, obviously this can affect to a larger or lesser degree. We're not really that close to oceans, so that may not be one that affects our. Sometimes we get an effect if we get the tail end of hurricanes or things like that, but we're not really close to the ocean. Winds and air masses. So I talked about how winds are variable in the short term, but over the long term, it's quite predictable where the winds are coming from and what the air masses will be like. So air masses are just huge kind of pockets of air that are similar. So everything within this pocket is similar in terms of its moisture content and temperature. So they call that an air mass. Elevation. So how high above sea level are you? We're not anywhere close to the mountains here, but if we were doing this out in, Alberta, British Columbia, and the Rockies, we would be talking about the major influence of elevation. Relief. So relief is related to elevation, but not quite the same. So relief looks at changes in elevation, the topography of the landscape. And why that's important, we'll get to very shortly. And lastly, how close are you to big bodies of water? So obviously, I said that we're not really close to the ocean, so that doesn't affect us as much as it would out on the east coast of Newfoundland and Nova Scotia, or the west coast out in British Columbia, or even in the far north, um, where we have the Arctic Ocean up in the far north of Canada. So if we take a look at all of these together, we can remember all of these factors that affect climate by looking at the first letters of each of these: latitude, ocean currents, winds, elevation, relief, and near water. And we can remember that acronym: lower, near, water. And that will help us remember what are those factors that affect the climate. So let's look at each of these factors now. We'll start with latitude. And latitude has a big effect on the climate of an area. We know that if you're near the equator, you're warm. We know that if you're further away from the equator, you're not so warm. And at the poles, you're cold. So why is that the case? Well, if you look at the diagram here, it has to do with the angle at which the sun's rays hit the planet. And if we imagine the same intensity of sunlight at the top here as we have at the equator, you can see that that same amount of intensity is spread out over a much larger area closer to the poles. It's more diffuse because of the angle at which it's hitting the Earth, because of the curvature of our planet. Whereas if you look near the equator, you can see that that same intensity is striking the planet uh, at a much more direct angle. So that same intensity is more concentrated. And since it's more concentrated, more intense, it's going to be warmer. When it's more spread out near the poles, everywhere in that circle that you see there doesn't get quite as much of that intensity of the sunlight compared to that smaller, more concentrated area near the equator. Ocean currents. So if we look at ocean currents, they can have a very large effect. And obviously latitude, so we just learned that the further north or south you are of the equator, the colder in general it gets. That's true, except it can also be influenced by these ocean currents. For example, if we look at the east coast of Canada and compare it to the west coast of Canada, parts of southern BC are actually at the same latitude as parts of Newfoundland. And they have vastly different climates. So latitude isn't the only factor here. Ocean currents play a major role. Blue is cold, red is warm. You notice that very cold Labrador current coming down from the Arctic and hugging the east coast of Canada, Labrador, Newfoundland, and Nova Scotia. That leads to colder temperatures. Obviously, if you've been out there, your family's from there, you get a lot of snow in the winter. Whereas if you're out in BC, they barely get any snow ever, even though they're at the same latitude. And that's because they have a warm ocean current coming up the coast, the west coast of Canada. You can also see that because that cold Labrador current interacts with that warm Gulf Stream that's coming up, what you get, and again, if you've been out to the East Coast or your family's from there or you go visit sometimes, you get a lot of fog caused by that convergence of the cold Labrador current with that warm Gulf Stream and causing a lot of fog on the East Coast. Here's a map that looks at currents all over the world. Again, I'll focus on Canada here. So you can see, if you can follow my cursor, on the west coast of Canada, red is warm, blue is cold. So at the same latitude, here's Vancouver Island. So Victoria's about there. If we were to follow that line of latitude, it goes all the way across to Newfoundland. But since we have this warm current coming up from the tropics on the west coast of Canada, we get much warmer temperatures than on the east coast where we have this cold Labrador current coming down from the Arctic. Okay, winds and air masses. So an air mass, as I said, is like a huge parcel of air that is homogeneous, meaning it has the same temperature, moisture content, right? So it's a big, you can't see it, but a big parcel of air that all has the same temperature and moisture content. And over continents, that air mass, they call them continental air masses, are drier, so they don't contain a continental air mass doesn't have that much moisture in it, and it can be either hot or cold depending on where it's coming from, what time of year it is, etc. Whereas maritime air masses are ones that form over water, contain a lot more moisture, but don't have the temperature extremes because water moderates that temperature, so it doesn't have those temperature extremes like continental air masses do. So if we had a very hot continental air mass blowing in from a certain direction, well, that's going to warm you up. If you have a maritime air mass coming, then you know you're likely to experience some rain or snow depending on the time of year. And again, over short periods of time, the wind can be quite variable. But for example, in Canada, and I'll show you a picture in just a second, the prevailing direction of the wind, meaning the direction from which the wind most often comes, is from the west, and they call them westerlies. So it's very predictable over long periods of time. There's also something called the jet stream, and the jet stream is a current of wind that moves very quickly from west to east across North America. And it changes its position changes from summer to winter, and its speed also does. Uh, and it is always present. So this is why if you've ever flown from London or Toronto or Detroit out west, maybe to, Alberta, or maybe to British Columbia, or maybe even to California in the States, the trip from Toronto out west takes a lot longer than the trip from, say, British Columbia back to Toronto. And that's because those pilots are able to use the jet stream. So they might use the same uh, amount of fuel and get there an hour quicker or 2 hours quicker because they're riding that jet stream. They're getting a boost of anywhere between 60 kilometers an hour and over 100 kilometers an hour from that jet stream. Okay, elevation. So elevation, we're talking about how far above sea level are you? How high above sea level are you? The higher up you go, the lower is the temperature, all other things being equal. And we can actually measure that. So as you increase your elevation, the temperature, depending on the moisture content of the air, will drop between 1 to 2 degrees Celsius for every 100 meters you go up in elevation. And that's because as you move up, the air is less dense, and that decrease in density prevents it from holding as much heat as it can at lower elevations. So they call that the adiabatic lapse rate. You don't really need to remember that term, but it's a good term. So, why not? Um, if you look, they do differentiate between the wet adiabatic lapse rate and the dry adiabatic lapse rate. And it's anywhere between, as I said, 1 to 2 degrees Celsius per 100 meters. Or if you're looking per kilometer, that's 5 to 10 degrees Celsius per kilometer. And you could see if you were at sea level on this diagram, or ground level anyway, it's 32 degrees Celsius, so it's a nice summer day. If we were closer to the mountains and we could hike up, and we went up 1,000 meters, all of a sudden that 32 degrees becomes 22 degrees. Likewise, if it was not a warm summer day, that means it could be a cool fall day, maybe 10, 11 degrees on the surface. And then if you went up a bit higher, it's snowing. And that's why, of course, we see often mountain peaks having snow on them all year round, whereas down at the bottom of that mountain, it might be 20, 25 degrees. Relief. So, relief is related to elevation, and relief looks at topography. So, the changes in elevation of the surface of the planet. So, what this does, those air masses I talked about, they can't go through the land, right? They have to go over, above, come back down. And depending on that change in elevation, you're going to get a different reaction from those air masses. So, what usually will happen, and what does happen, particularly if you look at places like the west coast of Canada, you're going to get often cooler, wetter climates on the windward side. So, that's the side from which the wind is coming. And those air masses will have to climb over top. And then on that leeward side, which is the opposite side, you're going to get much drier uh, conditions because those air masses will have lost all of that moisture. So they've dropped all the moisture on the windward side, and they'll have lost it by the time they get to that leeward side. And you can see it in this diagram here. So imagine this being the west coast of Canada. So here's the ocean right there. That's the Pacific. So you're going to get evaporation off of the water, and the wind, remember we said it's westerly, so it's coming from the west to the east. It's going to hit this mountain and have to climb. So when it starts to climb, what happens is, remember, it decreases in temperature as you go higher up. Those air masses, as the temperature goes down, they're not able to hold as much water. So warm air can hold more water than cold air. So as that air rises, the temperature falls, the ability to hold water decreases, so it becomes saturated. It has to drop that water. So it drops the water as rain. So you often get lush vegetation on that windward side of mountains. And then once it's dropped that moisture, so this is like the Okanagan Valley in British Columbia, where you're able to grow grapes and it's very lush and green. Once you get over this mountain and the air has lost all of its moisture, it's going to come back down. And since it is pretty much out of moisture, it can actually even pick up moisture from the soil itself, causing very dry conditions on the leeward side. And they call this the rain shadow. And in severe enough conditions, it can be the difference between rainforest on the windward side and almost desert on the leeward side. Last one is proximity to water. How close are you to water? So, water has what's called a very high specific heat capacity, meaning it takes a lot of energy to heat water up by any significant amount. And why that's important to the overall climate is that has a moderating effect. So if you're close to the lake, and you might know this if you've ever gone to Toronto and you're right in the city, it could be hot in the summer, right? Especially because Toronto's so paved and it has um, all those big buildings with windows that reflect uh, the sunlight. So it might be 34, 35 degrees in the center of Toronto. But then you go down by Lake Ontario to the waterfront, and it might drop as much as 7 or 8 degrees, 34, 35 right in the center of Toronto, and maybe 25 down by the lake. So it has that moderating effect. In the summer, it won't be quite as warm, but in the winter and in the fall, it won't be quite as cold. So you don't get those extremes. It moderates both in the summer and in the fall and winter. Right. Also can affect precipitation. Obviously, one thing we get a lot of is the snowfall from lake effect snow. And that's where, if you've ever looked at the radar when we've had snow days, you'll often see these streamers, just little bands of snow that are just hitting London or Goderich or places like that and staying right over that city or right over that general area for a day or 2 days. And that's because the wind blowing over the lake. So what happens is, as long as the lakes are still open, not frozen over, that lake, remember, it takes a lot of energy to heat up. They heat up slowly, but they also cool down slowly. So that lake is warmer than the air above it. So it's actually going to give moisture, warm that air up a bit, take that moisture and send it whatever direction the wind is going. And if that happens to be London, Ontario, well, it's going to dump that moisture after that air cools down again. Because remember, cold air can't hold as much moisture as warm air. So it gets a bit warmer over the open lake, picks up some moisture. As soon as it gets to land where it's no longer warm, it's cold, it's got to drop that snow. And that's where we get pounded with lake effect snow. Okay, that's it. So what I'd like you to do now, and you can just, I'll put on a little Google Doc. I want you to tell me what of those factors you think, which of those factors are most important in affecting the climate of London, Ontario, Canada. So of the latitude, the ocean currents, the wind, elevation, relief, and nearness or proximity to water, which factors are most important in London, Ontario, Canada, and why? All right, and that's it for today. So now that we know the baseline, we have established what these factors are that affect climate. Next, we'll look at how climate is actually changing and what those causes are, and in particular, what human beings are doing to cause the changes that are occurring with climate. Okay, I hope you guys are having a great day. Get outside if you haven't already. It's beautiful out there. And this will be the last post for this week. So next week, we'll start learning about how climate is changing and what we as human beings are doing to make that change. That's for me. Bye, guys.